Hi, Sally Walker here, your hormone and slow age expert. So how do we get glucose into the cell? Because listen here, people. Cells have a double layer of fat all the way around. It's called the cell wall or the cell membrane, and it's made of fat. So any molecule which is water soluble needs help to get in because water soluble doesn't go through fat. And your glucose and your amino acids are water soluble, so they need assistance. Okay, so how does this work? Okay, so in the cell walls or the cell membranes, there's lots of what we call receptors. Just think of those as being like keyholes, if you like, or letterboxes as well, I suppose, or the doorbells, we could call them as well, really. Anyway, think of them like that. And what happens is that various different molecules can come along and they can lock on to the keyhole or they can ring on the bell and they can tell the cell, the inside of the cell, certain parts of the cell, that there is something outside that wants to get in. Could you please open the door? Yeah? And that's what happens. So with your muscle cells and with your fat cells, insulin is the molecule that comes along, finds its keyhole and locks on and rings on the doorbell or bangs on the door and says, "Hello, Mr. Fat Cell," or "Hello, Mr. Muscle Cell. I have loads of glucose and I also have some amino acids. Are you interested?" So a scenario could be that the muscle cell says, "Oh, thank God you came. We are so hungry. She's been exercising all morning. We're absolutely starving." Okay. So then what happens is on the inside of the cell, there's something called glucose transporters. Now they are found actually in all cells, but in muscle cells and fat cells, insulin calls them. So what happens is these glucose transporters go to the cell wall and they make an entrance. They make a passageway. So all the little glucose molecules and all the little amino acids can go into the cell and the cell's happy. It now has more glucose. It now can make more muscle tissue, etc. with the amino acids. And blood glucose levels begin to fall. So the pancreas is also very happy and the brain is very, very happy and says, "Oh, we don't need to produce more insulin because we've sorted out the blood glucose levels." Everyone's happy. Yeah. So if it was another scenario and the muscle cell or insulin came along, banged on the door and said, "I've got loads of glucose, lots of amino acids, are you interested?" And the muscle cell could say, "No, we're not interested. No. She's been sitting on the sofa all day watching Netflix and eating popcorn. We do not need any more glucose. Thank you very much." Now, with that scenario, the blood glucose doesn't decrease and the brain gets involved again and it says, "What's going on down there, Mr. Pancreas? Can you produce some more insulin? We need to get this blood glucose down because it's too high. It's dangerous." So the pancreas produces more insulin and insulin may come along again and bang on the door. And the muscle cell is still saying, no, we do not want any glucose. She hasn't used up the glucose that we have. Now, if that continues, then you have the state called insulin resistance. So the muscle cell is saying, "No, thank you," doesn't want to have any more glucose. The little fat cells, now it takes much longer before they say no. So when the muscle cell initially says we don't want any more, the little fat cell says, "Come on, come over here, bring it on. We can take loads and loads and loads of glucose, thank you." And it's longer, it takes a longer time, but eventually if you don't control your blood glucose levels, then the fat cell will also say enough is enough. And then you're in really big problems, okay? So these glucose transporters are very, very important. But as I said, in muscle cells and in fat cells, they need to be called these glucose transporters. But in other cells, in your brain, in your pancreas, in your liver, in your kidneys, in the testicles as well, they don't need to be called. They will automatically, as their blood glucose levels drop inside the cell, it's not the blood glucose, as the cell glucose levels drops, they will automatically go to the cell wall to bring in some new glucose. So they're regulated by a completely different way. But insulin is important for muscle cells and for fat cells. So these glucose transporters, they have fancy little names. Well, they don't have fancy names. They're just called GLUTs. GLUT, G-L-U-T. And there's GLUT1 and GLUT2 and GLUT3 and GLUT4 and even GLUT5. So it's the GLUT4s. These are the ones which are dependent on insulin to call them up to the cell surface so we can get the glucose in. Yeah? Have a little look at the article, have a little look at the blog, and check out the other videos while you're there. By the way, the solution isn't more insulin because the cell's still going to be resistant. The solution is making sure your blood sugar isn't too high. So the solutions will always be things to do with diet changes, low carbohydrate or lower carbohydrate, getting more sleep, getting more rest, getting more exercise. All these things are very, very important if you want to decrease your need for insulin. Happy hormones, happy life.